Hello, in this video I'm going to be solving exercise 3.3.104 from Jiří Lebel's notes on Diffy Qs. So we're given this system right here in two parts. So part A wants us to write this system in matrix notation, and part B wants us to solve the system and then write its solution in matrix notation. Okay. So first for part A, so we need to write this as a matrix, and to do this, one thing I find that really helps is to add all the variables that appear or that we need for like our matrix. So let me explain what I mean by this. So here we have two quantities of interest, x1 and x2. And so when I'm writing out my equations to set them up for matrix notation, I'm going to add in all of the missing things in each equation. So here in this first one, we can see that I'm missing the x1 terms. So what I'm going to do is I'm going to artificially add them in by doing 0 times x1. And then I'm just going to add in the thing that we know is there, 2tx2. This is the same as the original equation here because 0 times x1 is just x1. So we're not changing the values of either side. Similarly, I can take the second equation, x2 prime, and we're missing the x1 here too, so I can do 0 times x1, adding in this variable x1, and then add in what's left, x2. Once we're here, all we need to look at is, and quick remark, when we want to set up for matrix notation, we need to be consistent on whether we write x1 first, then x2 from left to right, or x2, then x1. Now, as a general rule, I think it's always a good idea to start with x1, then x2, because in most problems that you encounter in practice, that's how they're going to be like numbered, but there's some room for freedom. Let's stick with this way. So I'm writing all the x1 terms first, then the x2 terms. And we can see that on the right side, this is consistent on both equations. So I have x1, x2 from left to right on the second equation too. Once we have it in this way, we can rewrite this system as follows. So what I'm going to do is I'm going to take the left side, I'm going to package it into a vector, column vector. And then the right side, I'm going to add in this matrix, x1, x2, or actually here, I'll get to this part in just a bit. On the right side, I'm going to look just at the coefficients for x1 and x2, for the different variables in my system, the different functions. And as they appear on the right side, so if I just like ignore the x1 and x2 and the plus signs, I'm going to add in these quantities into this matrix here. So on the top, I have 0 and 2t, so I'm going to add 0 and 2t. And similarly, on the bottom, I have 0, then 2t, so I'm going to add 0, then 2t. And because on the left side, I've set it up so that x1 prime is at the top, x2 prime is on the bottom, I'm going to take my functions x1 and x2, and I'm going to order them in the same way. So it'd be x1 and then x2. Notice also, this isn't part of the problem, but let's just suppose that we also had some extra terms, f of t rather, plus g of t. Then we would package these into our matrix equation by just adding a column vector for these guys, like this. And so that would give us our matrix equation. Now let me erase these because they're not part of the problem. But as written here, this is the matrix equation, or the matrix notation for the system above. Okay, now let's do the second part, 3.3.103b, 104. And so now we need to solve this system and write the solution in matrix notation. Now, to solve the system, we do need to use the original equations here. So unless we had been given constant coefficients, in which case the techniques of the next section, 3.4, apply, but we're not in 3.4, we're in 3.3. So we're going to solve the system by hand using just the equations up here. So first notice that x2 prime equals 2tx2 is just the first order ODE for x2. It's a linear first order ODE, in fact. So this only depends on x2, not on the other function. So this is a first order linear ODE for x2. And we know how to solve these. Alternatively, we can also recognize this as a separable equation. Either one is fine. So let me add that in as a remark. Alternatively, we may see that x2 prime equals 2tx2 is separable. And regardless of the method you solve it, so like here I'll solve it as a linear ODE. So here we have x2 prime minus 2tx2 equals 0. We're going to see that the solution is going to be, the solution family rather, is going to be c2 e to the t squared, where c is a constant. All right, so how do we get this? Well, first, let's multiply by an integrating factor. And here, integrating this, it's not hard to see that we get negative t squared. So e to the negative t squared, x2 prime minus 2t e to negative t squared, x2 equals 0, which gives e to the negative t squared, x2 prime equals 0, which gives this is some constants, and therefore x2 must be c e to the t squared, as claimed. So now we know what x2 is. Now let's solve for x1. So, and for this, we're going to use the other equation. So we know that x1 prime equals 2tx2, but we just found what x2 is. It has to be c e to the t squared. So this is c times 2t e to the t squared. And so then when we integrate, we get, factoring out the c, 2t e to the t squared dt. And if we do a u sub, u is equal to t squared, we get c integral e to the u du, which is c e to the u, which is c e to the, oh, and I forgot, there's another constant, plus d. So this is c e to the t squared plus d. So now that we have our solutions, x2, and then over here is x1, let me summarize them over here. So x1 is c e to the t squared plus d, and x2 equals c e to the t squared. We can write this using matrix notation by just taking our column vector for x1 and x2 and plugging in the things that we found and simplifying wherever we can. Oh, not a division sign. We're not dividing here. So here we can clean this up a bit if we wish. So we can collect the like term c e to the t squared, and then CE to the t squared. It's d over 0. What I'm doing right now isn't strictly necessary, depending on whether, like, what the exam standards are. Like, maybe it's okay to leave it like this. If you want to write it a different way, you could also express it like this. So you could have CE to the t squared. Just factoring out this from each of the components, we get 1, 1, and then plus d over 0, d, not b. And so this gives another way to express the same solution as a matrix. Again, either one of these is technically in matrix notation. Which one is preferable depends on like the exam constraints or whatever your needs might be, but they're both perfectly okay. All right, that's it for this video. If there are any questions, please feel free to leave a comment. Otherwise, I'll see you all in the next video.